let's look at the derivative of tan x. These are some key notes that we'll be using. So we can start by letting f of x equal to tan x, and then we know that the derivative of f of x is written as f dash of x, which by using the formula for differentiation from first principles, we have equals to the limit as h tends to 0 of f of x plus h minus f of x all over h. And so we now have that f dash of x equals to the limit as h tends to 0, and now f of x plus h is equal to tan of x plus h minus f of x, which in this case is minus tan x, all over h. Now we can write this as f dash of x, which equals to the limit as h tends to 0. And so if we use the addition formula for tan, we end up with the following. So we have tan of x plus tan of h all over 1 minus tan of x times tan of h minus tan x all over h. Now, since we have a fraction within a fraction, what we're going to do is multiply both the numerator and denominator of the outer fraction by this denominator here, 1 minus tan x times tan h. We end up with f dash of x, which equals to the limit as h tends to 0. Now multiplying the first term by this denominator, we end up with tan x plus tan h, and now we're going to multiply minus tan x with this denominator. So we have minus tan x, and then in brackets 1 minus tan x times tan h, and then in the denominator we now have h multiplied by this expression here. So 1 minus tan x times tan h. Now we can use the small angle approximation for tan h, which approximates to h. And so we end up with f dash of x, which equals to the limit as h tends to 0. And now tan x stays the same. Tan h can now be written as h. And then we have minus tan x. And then inside the brackets, we get 1 minus tan x times, instead of tan h now, we can write h all over h brackets 1 minus tan x, and again instead of writing tan h we can now write h, and so we now get f dash of x, which equals to the limit h tends to 0, and now expanding the brackets in the numerator we get tan x plus h, and then minus tan x times 1 is minus tan x times minus tan x times h is plus tan squared x times h, and then in the denominator we now have h brackets 1 minus tan x times h. Now we can simplify the numerator, so we end up with f dash of x, which equals to the limit as h tends to 0, and now tan x minus tan x cancels. And we also have that h is a common factor of both of these terms. So factorizing the h out, we end up with h and then brackets 1 plus tan squared x all over, and now we have h brackets 1 minus tan x times h. Now we can see that there's a h in the numerator and denominator that's being multiplied, so we can cancel these out. Now if we apply the limit as h tends to 0, we end up with f dash of x, which equals to 1 plus tan squared x all over 1, and now we have tan x times 0, which is 0, and so we're subtracting 0. This simplifies to f dash of x, which equals to 1 plus tan squared x. 1 minus 0 is 1, and then divided by 1 leaves us with 1 plus tan squared x. And now finally, we know that 1 plus tan squared x equals to sec squared x, so f dash of x equals to sec squared x. And therefore the derivative of tan x is equal to sec squared x.